3 supermassive black holes were just confirmed feeding inside a single galaxy. And nothing like it has ever been seen before. The James Webb Space Telescope caught the galaxy, catalogued as JO1484214, as it looked roughly 1.2 billion years after the Big Bang. More than 12.5 billion light-years away. 2 of the black holes sit near the galactic center, separated by only 620 light-years. Close enough that astronomers expect them to merge within a few 100 million years. A third sits far out in the galaxy's outskirts, about 5,500 light-years from the middle. Pairs of merging black holes have shown up before. A confirmed trio, in one galaxy, this early in the universe's history, has not. Today we look at how a telescope catches 3 feeding black holes without seeing any of them directly. Why this early era of the universe is exactly where you would expect a pileup like this. And what still has to be checked before anyone calls this settled. No telescope photographs a black hole directly at this distance. What Webb picked up instead was infrared light coming from gas and dust being violently heated as it spirals toward each black hole. The signature astronomers call an active galactic nucleus. Each of the 3 sources in JO1484214 showed the specific spectral fingerprint of that superheated inflow, not ordinary starlight, which is how the team led by the Max Planck Institute for Extraterrestrial Physics separated black holes from star-forming clumps. The masses come from that same light, roughly 80 million, 2 million, and 600,000 times the mass of the Sun, confirming 3 separate sources instead of one smeared, ambiguous blob required Webb's sharper resolution compared to earlier space telescopes, plus follow-up spectroscopy to check that each signal held its own distinct chemical and velocity signature. That is also the honest limit of the method. You are reading the glow of infalling material, not photographing the black holes themselves. So every mass and distance estimate depends on how well that glow has been modeled. A galaxy this early is not a calm, settled place. Just over a billion years after the Big Bang, small galaxies were colliding and merging with each other constantly as they grew into the larger structures seen today. Every galaxy that merges with a black hole at its center drags that black hole along. So a galaxy that has swallowed 2 or 3 smaller galaxies in a row can end up temporarily hosting 2 or 3 black holes at once, before they eventually spiral together and merge into one. JO1484214 fits that picture. 2 black holes close enough to merge soon, and a third still working its way in from the outskirts. Arguably a snapshot of a merger in progress rather than a finished result. If galaxy mergers really are what builds the giant black holes seen billions of years later, catching one caught mid-pileup this early is close to direct evidence for that chain of events, rather than a model run on a computer. That is what makes this find matter beyond the record for most black holes photographed in one place. This is one galaxy. A single confirmed triple system does not tell you how common this arrangement actually is in a early universe, only that it happens at least once every mass, distance, and merger timeline estimate here comes from modeling infrared light, not a direct measurement. So refinements to that modeling could shift the numbers, including the widely quoted merger timeline of a few 100 million years for the inner pair. The outer black hole is also the shakier part of the claim. It sits far enough from the other 2 that confirming it is gravitationally bound to the same galaxy, rather than a separate object lined up by chance along the line of sight, took extra scrutiny. And some astronomers in the field want independent follow-up before treating it as settled. None of that erases the 2 inner black holes, which are well established. But the full trio, and especially what it implies about how often this happens, is a first data point, not a pattern. One galaxy is a discovery. It is not yet a rule about how the early universe built its biggest black holes. Recap. The James Webb Space Telescope found 3 supermassive black holes feeding inside one galaxy from just 1.2 billion years after the Big Bang. 2 close enough to merge within a few hundred million years, and a third still spiraling in from the outskirts. The first confirmed triple black hole system ever observed. Signal or noise? Mostly signal. The 2 inner black holes rest on solid spectroscopy, and the whole picture lines up with what galaxy merger models already predicted about how the universe's biggest black holes got built. Where this shades toward noise is any headline treating one galaxy as proof this is common, or treating the outer black hole's membership in the system as fully settled rather than still being checked. The honest version. Astronomers caught a black hole pileup in progress, in a galaxy old enough to have been forming when the universe itself was young. And now the search is on for a second one to prove the first was not a fluke. Subscribe for the science stories that survive the fact check. Signal from the noise. Every week.